Hi, this is Mr. Courteau, and I'm going to do another screencast of how you solve some of the problems on page 4 using the Moapahe'e. Okay, let's start by reading the first sentence. It says, the momentum of an object is a product of its mass and its velocity. Okay, so let's look at that. See, here we have highlight up what's really important. So momentum, right? That's really important. Mass, really important. Velocity is really important. And then we have this word product here. Okay. Remember, product means basically that I'm going to times something or multiply it. So when we use the word momentum, a lot of times we use symbols. And the symbol for momentum is this, it's a Greek letter mu. Okay, that I use that. My symbol for mass is a small letter m. Okay. My symbol for velocity is a small letter v. Okay. When I time something, I don't use x because that would be confusing because, you know, I'm using all these letters. So I actually just use a dot to symbolize that. So let's rewrite what our equation is. It's mu, or momentum, is equal to the product of the mass and the velocity. Okay. I'm going to box that up because that's my equation that I'm going to use. Okay. Now, farther down it says the more momentum an object has, the harder it is to stop. For example, you can easily catch a feather drifting sideways along the sidewalk, but you would have a hard time stopping a giant 10,000-pound bowling ball rolling down the street at the same speed. Why? Because the giant bowling ball has more momentum. Why does it have more momentum? Well, that's simple. It has a lot more mass, right? It has greater mass. So something that's moving with a lot of mass has a lot of momentum. So let's look down at this. I have a little example. It says, describe another situation. So I want you to think of something totally different from this. My situation here is I have this big semi-truck, right? And here it is right here, and you can see it. Now, if I just put this on a regular old street and it's not moving and it's just stopped there, would it have any momentum? The answer is no, it wouldn't have any momentum because it's not moving, so the velocity is equal to 0, right? If it's not moving, 0 times the mass, even though it's a huge truck, would be 0, so the momentum would be 0. Now, if we change this situation and we say, okay, let's give this a little, and then put a driveway here. And then here you are playing at the bottom of the driveway. Okay. And this truck came out of gear and started to roll down the driveway towards you. Would it have a lot of momentum? The answer is yes, it would. You'd want to get out of the way. That's not very good for you. You'd want to actually move. Oops. Okay, you'd want to move because that truck has a lot of momentum because it's a big truck with a lot of mass, right? And it's moving, right? So it has velocity, so it would have a lot of momentum. Now, say your little brother is out there playing in the driveway, right? Here he is, moving around, and there's big trucks out in the street, you know, going back and forth, and your little brother starts to ride down the driveway, okay? Could you stop him? Yeah, you could, because your brother's not very big, and he doesn't have a lot of momentum, so you could actually stop your brother from driving out into the road and running into the street, right? Because you can stop him because his mass is kind of small, right? He has a very small mass. And so that's a situation, and you could think of something very similar to that, right? Could you stop, what could you stop? Or could you catch something? And for instance, could you catch like a bullet? Could you? It has a lot of momentum, right? Now, bullets aren't very heavy. They don't have a lot of mass, but they're moving very, very fast, right? And so because they're moving so fast, they have a lot of momentum, right? But if I threw a marshmallow at you, could you stop it? Yeah, you could, because even if it was fat, you know, because it doesn't have a lot of mass, and it's probably not flying very fast, right? It's not moving, the velocity, the rate of travel isn't very fast, so you could So that's what momentum is. It's mass times velocity. And when we look farther down here, what I want you to do is I want you to use that equation. Let's rewrite it again. It's mu equals, right, mass times velocity. And I want you to find that momentum of these two objects. So when I look here, this one says that there are these two different MOAs, right? A MOA with a mass of 0.75 kilograms travels at a 2 meter speed. Okay? The mass is 0.75 and travels at 2 meters a second. Right? The other one says you have a second MOA, right? Second MOA with a mass of only 0.35 and travels at 4 meters a second. So here's how I'd solve this up. I'd say, well, mu, and we'll just call this mass number 1, or momentum 1. There's a bell. Momentum 1 equals, right? The mass is 0.75 kilograms times the speed, 2 meters a second. This is kilograms. So we'd be able to multiply this up, right? And you'll be able to figure out what is going to be your answer. And the units are kilograms, meters a second. And then you have your momentum 2 of the second MOA. Now this one's lighter, right? It's 0.35 kilograms. But it's traveling faster, so it's moving at 4 meters a second. So again, you find out what this one's going to be, right? And the answer is going to be kilograms meter a second. Right? Circle that answer. Now, problem is, what I want you to say is which one has more momentum? Well, the one that has the greater number, whatever it is, this one or this one, whichever one is greater is going to have more momentum. And finally, what do you want to do? Answer with a complete sentence. Okay, that's how you solve the first and the second one. You figure out the